We're taking advantage of two real land resources here in Iceland. There's no oil, there's no gas, there's no major mineral deposits. However, we do have two things. We have water, one of our most important resources. Water coming in the form of precipitation, like rain and snow, glacial water, surface water. This water is leaking down into the rock and creating a large underground aquifer system. Within this aquifer system, it can come in contact with one of Iceland's other great resources here on the land, volcanic heat. So here at the power plant, we're actually in the beginning of the foothills of a volcanic system. Out this window here, this is the Hellisheidi volcano. And what we've done here at the power plant is we're drilling down into the ground. We're drilling down 1,000 to 3,000 meters into the area where this underground water has come in contact with the underground heat. Down there, we're getting very high temperature fluids, so high temperature steam and some liquid water. With that, we're doing two things. We're creating electricity, so 300 megawatts here at the power plant. For perspective, that's about twice what the city of Reykjavik needs. But also, and probably most importantly, is we're creating hot water. I say most importantly because within Iceland, around the island, the entire country, about 90% of the homes are heated by geothermal hot water. Within the city of Reykjavik, that's about 100%. So we're literally heating our homes with the heat of the earth. All of these radiators you see running through the windows, that would be geothermal hot water. All of your heated tiles are large outdoor swimming pools heated in the earth. So, if you'd like to follow me, this has seen one of these before. This would be a steam cutaway of a steam turbine. It's very similar to a coal or nuclear power plant steam turbine. There you're burning coal to create steam, or using the decay of uranium to create steam. Here in an area with geothermal resources, we're using the steam directly out of the ground. To sort of describe how this works in a very brief introduction to thermodynamics, we have high pressure steam coming in this section of the turbine. So through this pipe here, it's under a lot of pressure, and there's an area of low pressure over here. There's a wider area, so lower pressure. So if you think about it, it wants to move that direction. It wants to move towards the area of lower pressure. When it does, it spins these turbine blades. These turbine blades are attached to a shaft, and on this end of the shaft we have an electricity generator. We generate electricity. I think the beauty for me, at least as like an energy scientist, would be that this is industrial revolution era technology. We're using 200-year-old technology just for a sustainable, renewable way in this kind of power plant. Okay, so it's one of the largest, large hill in the middle of the town of Reykjavik. Sits up on a large hill near the domestic airport. This building actually serves a purpose, however. These are hot water storage tanks for the city. Hot water taken from power plants like this and others, as well as shallow wells within the city of Reykjavik. They're pumped up into these tanks, and because it's on a large hill, distributed by gravity to people's homes. And because Icelanders like turning utilities into tourist destinations, you can have a coffee and a nice dinner.
So this is Dr. D. He's a geothermalologist, and he is going to tell us how the power station works.
Thanks very much, Steph. Well, here we are at Hellisheidi power station, geothermal power station, and we're about 30 kilometres northeast of Reykjavik, the capital city of Iceland. And behind me you can see lots of steam. And this is waste steam from the building behind us. Why don't you turn around and just sort of say where we are? Well, it's not very interesting, it's steel wool, but in there are 4 steam-powered turbines, and they generate about 300 megawatts of electricity. That's more than enough to power all of Reykjavik, which is the capital city, so a lot of electricity. And that's all free, clean, sustainable, unlimited energy from geothermally heated water. So here in Iceland, about 3 kilometres under our feet, we've got rocks that are getting close to magma. They're many hundreds of degrees Celsius in temperature. That's hot enough to superheat water, which rises up to the surface in pipes that they drill in the power station and spins round these turbines at about 3,000 revolutions per minute, and that generates electricity.
Thank you very much. So where does the water come from?
Well, as you can see, there's lots of snow behind us. We're in May at the moment. There's still lots of snow on the ground, and it rained an awful lot yesterday. And that's really key to this geothermal energy production. Not only do you need heat underground, but you also need water to turn into steam. So all this snow and precipitation, rain, melt and percolates down through cracks in the volcanic rock where it comes into contact with the magma and becomes superheated into steam and rises up to power the power station. So it's the combination of these two elements, fire and water, that enables the production of geothermal energy.
Thanks.